Link for feedback will be shared at the end of the session in the chat box and will be active only for 1 hour. Participants are requested to pin the speaker during the session. Participants are requested to turn off your microphone and video. Dear participants, greetings to all. We welcome you for this workshop organized by St. Joseph Institute of Technology, OMR, Chennai. all of you who have joined here. On behalf of St. Joseph Institute of Technology and Department of Mathematics, I take immense pleasure in welcoming you to this second day of online workshop on exposure to data analytics software. Today we are honored to have Dr. A. DavidMaximGururaj to enlighten our knowledge. Professor Dr. A. DavidMaximGururaj is from Mathematics Division, School of Advanced Sciences, Vellore Institute of Technology, Chennai. He received his doctoral degree from Bardiyar University, Coimbatore. To his credit, Sir has published more than 20 research articles in Scopus indexed and peer-reviewed journals. He has 20 years of teaching and 10 years of research experiences. His research area, which includes fluid dynamics to be specific MHD flows, hybrid nanofluid flow, past various geometries, MHD effect of blood flow, statistical analysis, and optimization. He is a member of editorial team of International Journal of Applied Science. He is also the editorial board member of Syria Journal of Mechanics and Syria Journal of Mathematics. He is also reviewed research articles in the esteemed journal Physics of Fluid. He has guided 15 MPhil scholars and currently 2 PhD students are working under his guidance in the field of hybrid nanofluids. We are very much delighted to have you here, sir. We thank you for acknowledging our invitation. Dear participants, if you have any questions during the presentation, please type them into the chat box. We will bring them up to the speaker after the presentation, and also we will have time for questions at the end. Once again, I extend a cheerful welcome to you all. Your presence makes us very happy. I hand over the session to Dr. A. DavidMaximGururaj, sir, to elaborate on today's topic, data analysis using R software. Over to you, sir.
Okay, so thank you. Good morning to one and all. At this juncture, let me give my thanks to my friend and colleague, Dr. S. Dhanachekar sir, who made me to be this part of this webinar. And I also thank the management of St. Joseph Institute of Technology and Dr. T.T. Raman sir and Dr. T. Kalyani ma'am, conveners for this program, and Dr. K. Satish and Dr. C. Sivapurna Priya, coordinators for this program. Okay, so and actually let me present my screen. Is my PPT is visible?
Yes, sir, it is visible.
Okay. So and actually this session will be going to be a hands-on, as well as we are going to see what are the important syntaxes which we can use for data analysis. So the organizers might have sent you some files, data files. Okay, and they're also they have asked you to go to R Studio Cloud, and create a login for you. I hope you have done that. Okay, so because today's session we will be working on R Studio Cloud. Okay, and even though it is better to have a software in your PC, for today's session we will be using R Studio Cloud. Okay, so with this thing, and this is my presentation. I have just planned to have in 3 modules. In module 1, I will be discussing how to install R Studio and how to use R Studio Cloud. Okay, then basic commands in R, then what are the basic data types in R. Okay, then in module 2, I will show how R can be used as a calculator for solving descriptive statistics, and how linear algebra can be addressed using R, because linear algebra is an important aspect of data analytics. Okay, which we'll be seeing later. And in module 3, we'll discuss how to import a data set. Okay, once the data set is imported, we'll see how to clean it. Okay, and how to perform descriptive statistics like chi-square, regression, correlation, all those. Okay, so now for persons who are new to the software, so here if you go to this particular sites, okay, rproject.org or CRAN is Comprehensive R Archive Network. If you go there you can download R. Okay, so once you download, you can see this. I've given a screenshot of this. So from here you can go and download R. Okay. Once if you download R, it is just based on the command prompt. See, in the next slide we'll be seeing. See, command line will be there. I'm going to type my command here to make this particular to use this particular software a little bit more interesting or more graphical user. I will suggest you to go and install R Studio. Okay. So remember, for R, if you want to use R Studio, definitely R should be there in your system. So you have to install R. You have to install R Studio. You can install the latest version. There's no issue in that. You can install latest version. And we are using R Studio. I'm going to use R Studio. Okay. So and TinR is also there. TinR is another GUI interface where you can use R. Okay. So if you are going to work offline, remember you should have R in your PC. You should have R Studio in your PC. Okay. Now for this entire session, we will try to work using R Studio Cloud. R Studio Cloud, where to find that? It is there. HTTP. This is the link for going for R Studio Cloud. Okay. So now actually, after seeing the syntaxes, we will be going for a hands-on session. So I request everyone to go into R Studio Cloud. Be ready. Okay. So the codes, my friend and colleague Dhanashir sir, he will be posting the codes in the chat box. You can just copy the code, you can paste it there, and you can run it. Okay. So no issues. Okay. So no need to worry. Just the codes are available. It will be posted then and there in the chat box by Dhanashir sir. You can just copy that and you can paste it and you can run. Okay. Now this is the screenshot of R Studio desktop. Okay. So it is very similar to your MATLAB window what Dhanashir sir was discussing yesterday. This is the area where I can give. This is the area where I can write my code. Okay. Suppose I need a code for more than one line, I can write here. Okay. I can give the code here. Then I can use this button, run button. Okay. And I can run it. Okay. And if you come to this area, you can see the current environment on which you're working. You can go to history to find what are the commands you have already used. Okay. And you can import data set. Okay. From here, everything you can do it here. And this is the console. Okay. If you are having only R, not R Studio, means you'll be having only this part. You'll be having only the console part to work on. Okay. Since you're having a R Studio, it is more over a graphical user. It will be very friendly. Okay. So this part gives me the output. Okay. Either I can go here and execute the line by line command, or whatever I execute here, I will get the answer here. Okay. And here I can see what are the files I'm using. And for whenever I go for any plots, that will be displayed here. And this packages, I will talk about this later because it is a very important aspect in R. Okay. You can view what are the packages available. Okay. And other help and other viewer. Okay. This is the screenshot of your R Studio desktop. Remember, this is a offline desktop. Okay. So in the next slide, this is your screenshot of R Studio Cloud. Today we are going to use this. See, I have logged in is using either I can use my Google account or my GitHub account. Okay. Or you can create a new account. I can use it. Once I go into this, it will ask you to create a new project. Once you create a new project, then I can work with this thing. So see, you're having the same window in the R Cloud also. Okay. So I can use this window here also. I can import all the packages, whatever necessary for my analysis. Okay. So today we are going to work with this. I hope you have gone into R Studio Cloud and you have created a login for you. If not, you can do it easily. Don't worry, it is an easy process. Go there, go to login. Either you log in with your Google account or the GitHub account, or then you will go inside. It will ask to create a new project. Create a new project, and you will be getting the screen, and you will be starting to use here. Okay, right. So this is the thing which you are going to use today. Okay, so it will be more interactive. Okay, instead of having this in your laptop, you can directly work in cloud. Okay. Okay. Now getting into the prerequisites for our analysis. So there are some basic commands in R which you should know. Okay. As I mentioned, installing packages and libraries are a very important aspect of R, because for example, I want to find the moments for my data set. So I have to include a package called moments. If I have to work on clustering, okay, yesterday Star was talking about clustering. I have to include the package called cluster. if I want to work with graphics, I have to install the package called graphics. So these packages are an integral part of our language. Okay, so how to install a package? Okay, so next question is how to install it. Either I can go here, I can give install.packages moments. So where to give this? Either I can give here, see, I've given install package moments, then I can run this. Automatically the package will be installed here. Once the package is installed, I have to load that package, so I have to give library moments. So this is one way of doing it. The other way is I can go here, click this, and I can directly install it from the CRAN repository. When I'm connected to internet, I can go here directly to the packages, then I can go here and fetch the package, then I can easily install it. Once it is installed, in the package list it will be displayed. I have to check the tick box, automatically it will be loaded. Okay, so there are two ways I can do. Either I can give my command here and run this, or I can go here and use a graphical user interface. Okay, right. So now, so this is installing packages. As I said earlier, installing packages is not enough. We want to load that package for our data analysis. So how to load it? So I have installed the package, okay, moments, and this is screenshot of that. Okay, then I want to load that. You have to give library moments. Remember, installed our packages. This package name should be within double quotes. Then here, library moments. So if this process completed, then this moments packages, it has been successfully loaded and it is ready for your analysis. Okay, now how to detach a particular library pack? For example, I want to detach moments. I can directly go to that checkbox and I can remove the tick, or in the command prompt I can give detach the package. What package? Moments. Yes, unload equal to true. You have to give unload equal to true. So that means you're telling to detach the package. Okay, so remember, package is the lifeline of our programming. So whenever you need a particular package, you have to install it and you have to load it. Once you feel this is no longer needed, you can detach that. Okay, there are some system library packages which is already inside, and user also can install more packages. We'll be discussing in the due course. Okay, now there are some inbuilt packages in R. Okay, for example, I have quoted two of them here. Mass is nothing but modern applied statistics using S plus. So what is this S plus? This was the forefather for R. From S plus only they developed this R. So a package is mass is there, which is nothing but a book. Okay, so once I put library mass, automatically this mass package is loaded. Similarly, if I want to use generalized additive models, I have to already which is there inside, so no need to install it. You just call it library mgcv, so that loads the package mgcv. Okay, so now you want to know what are the contents of your library package. Suppose I want to know about this moments. Moment is a package, I want to know about that. I can give library help equal to moments. If I give this and run this, I can see a documentation for that moments will be there. Inside that you can see when it was created, who are the authors, what are the function sets available, what are the data sets available inside. Everything is given in this documentation for the package. So it is there to be library help equal to moments. Okay, so right now just I'm going through all the commands, then I will be doing an answer also later. Okay, right now. So now, as Sir was discussing last class, once a good programmer always tries to release the memory which is no longer needed. That is, I'm creating a variable for my program, and after some time I feel that the variable is no longer needed. I have to remove the memory occupied by that particular variable. So the same thing I can do in R. That is, the command is rm. Suppose I'm having three variables x, y, z. Okay, I'm using three variables in the program xyz, and I feel it no longer that xyz is needed. I can give remove xyz. I can give rmx, or I can give rmy, or I can give this as together. So this, what happens, this removes the variable xyz from the memory. Okay, that is very important. Now to quit R, you go to prompt, you can give just q within brackets. So if you give anything within brackets, it is nothing but it is a function. It is a method. We call that as a method in a programming language, which gets some parameter. So I'm giving this. It quits the R. Okay. So these are some prerequisites. So remember what we have discussed now. We have discussed about how to install packages and how to load packages and where to find the documentation for the package. Why I'm giving more stress for packages? Because that is the lifeline of R programming. Okay. Because each packages has lot of built-in functions. You just call that, you will get your desired result. Okay. So now there are some help demonstration and examples in our commands, so which we will discuss one by one. So suppose I want to know about LM. What is LM? Linear model. I want to I want to know about the how to fit a linear model. What is the command? What are the parameters which it receives and its detail? I can give help LM within double quotes. I'm going to give the LM which gives me this history about the fitting LM model. So the LM is a method, is a function, so which go and fetches that and it tells me how to use it with an example. So this is help LM. Okay. Then if I want to go and fetch a manual for my R, I can do it from using help.start. If I give help.start, okay, it will take you to this where you can find the manuals, how to use R and what are the different functions available inside, what are the corresponding syntax, reference, everything will be available here. Okay. So the third one is, suppose I want to search a particular subject. For example, I want to know about data input. Okay. So I can give help.search data input. Okay. If I give that, it goes there. See, it goes and fetches here, and this tells me how to input a data. Okay. So this is another way of help command, which helps us to search by the subject on which we want. Okay. And the another thing is, usually the important command which you use for statistical analysis is table. Table is nothing but it gives the count. It fetches the frequency of the data. Okay. To know how to use table, I can give question mark table. Okay. Then you can see this particular thing will open. It talks about how we can use table, what are its parameters and everything. Okay. So please, if there is any issue, please let me know, because right now I can see only my screen. If there is any issue from your side, please let me know. Okay.
So now you can carry on, sir.
Okay. Okay. So now I want to find where my functions, in which package it is. Suppose I want to find where these functions are. I can give find LM. If I give find LM, it tells me this LM function is in package called stats. Okay. Suppose I want to know where is this mean function. If I give find mean, it tells me it is in base package. So usually R will have a base package. It says these commands are in the base package. So this type of syntax command will help us to identify the package in which your function lies. Okay. Then if you want to, if you know only some sequence of letters and you want to search that, means you can go for approx LM. So see, it fetches all the strings where LM is there. LM. So it fetches all these strings with LM. From that you can use the corresponding, you can retrieve your what you are searching for. Okay. And similarly, there are some demo plots which is inside R. So suppose I want to know about perspective plots. Okay, I can give demo presp. So it tells me what are the different types of perspective plots which is already inside. So you will be having the skeletal code for that. You can use that code for your own function. Okay. So similarly, you can have demo colors is there. Okay. So similarly, so many demo plots are there which you can easily explore. Okay. Now suppose I want to work with mean. I don't know what is the syntax of mean, is it? So how to work? So I can give example of within quotes mean. If I give this automatically it takes a data set, see 0 to 10 in 50 data points. Then it finds the mean. So this is syntax for finding the mean of X. Then it trims 10% both sides of this data set and it finds the mean. So it gives me how to use a particular function. Suppose I don't know how to write the code for this. If I give example of that, I can clearly see with an example how it can be done. Okay, and now so far we have seen some basic help commands. Okay, and example. So example is very important aspect, because if you don't know a function, you can give example of that within quotes. Okay, now for any programming language, data types are very important. Data types are very important. Okay, so here we are going to discuss few data types. That is, excuse me. So here we are going to discuss how to go for a vector. Okay, then I'm going to discuss about how to do matrix, then data frame. Okay, we do have factors, we do have arrays, we do have list, but the thing which I'm going to discuss now are frequently used data types in a data analysis. Okay, so if you want to know about arrays, list, you can easily explore that. So right now I'm going to discuss about vectors. Okay, suppose I'm having a data set, I can import the data set and work on that. Suppose I'm having some data which I want to key in. Okay, so I want to give it as a vector. Okay, for example, here I am going to create a vector called apple with colors red, green, yellow. Remember, apple equal to, this is small c. It's very case sensitive, so this has to be small c, red, green, yellow. So I can give double quotes also here. It doesn't matter whether it's single quote or double quote. I can use double quote. One can be double, one can be single. Okay. So if I give this and call this again, then I can see, yeah, apple vector has been created with red, green, and yellow. Okay. Similarly, I'm going to create a vector for a data set like this: 2, 5, 8, 19, 25, 12. I can put it in a variable called x. So that means I'm assigning my right hand side to left hand side. So x equal to c of 2, 5, 8, 19, 25, 12. And if I call that, then I can see this is my vector. Okay. You cannot mix character and a numeric value to create a vector. Remember that. Okay. So now this plays a very important part in our future slides. Okay. So we have created a vector apple and a create vector x. Now matrices. Okay. So matrices, it is in rectangular data set. Okay. So here I've taken, please you leave this because I've taken numbers for easily to understand. I want to create a matrix. Okay. Here I'm taking a 3 by 3. This you can leave this. It's a 3 by 3 matrix. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So I'm putting in a variable called M1. Let me store in a variable M1 matrix of C. What are my elements? It's 1 to 9, and I'm mentioning how many rows. N row equal to 3, n column equal to 3, by row equal to t. I will explain this after the M2. Okay. So if I give this, you can see 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is my corresponding matrix M1. Now let me give the matrix in another way. M2 equal to matrix of the same thing. M row 3, n column 3, but I didn't mention anything about this. What it implies, by default, R places the element column wise. See, 1, 2, 3 will be the first column, 4, 5, 6 will be the second one, 7, 8, 9 will be the third one. Okay. So in order to override that, by default, it always places the elements column wise. To override that, I have to use by row. I need the data to be placed by row. So I have to give by row equal to t. Okay. So this is the important aspect in matrix. So creating matrices. Okay. Whether you are mentioning by row equal to true, if you didn't mention anything, by default, it is placed column wise. Okay. Now, then data frames. So there is a difference between matrix and data frame. In data frame, each column or each attribute can be of different data. For example, one can be, for example, I'm talking about a data frame of say students register number. It will be an alphanumeric. Then age, it will be a numeric value. Then gender, it is going to be character. So such a data table is called a data frame, where it can have different modes of data. Okay. For example, let me create a data set for you. So I'm creating a data set gender, which contains gender, height, weight, age. Okay. So these are going to be my parameters for my data frame: gender, height, weight, age. for example, I'm taking some three data points inside for gender, male, female, and their corresponding height, their corresponding weight is there, and their corresponding age. So now I'm going to create a data frame. So let me put in a variable called BMI, data.frame. Remember, this is the syntax, data.frame. What are my parameters for this data.frame? It has to be gender, it has to be height, weight, and age. And if I call this, see, you can see this is the data frame. Okay, a data frame is created. Okay, so you can see gender, it is in character, this is the numeric values, and these are numeric values. So whatever we have seen so far, we will go to the RStudio Cloud and then execute and come back. Okay, so now I'm going to RStudio Cloud. Okay, hi sir, Dhanashir sir. Dhanashir sir.
Yes, sir. Yes, sir.
Okay, you can paste the comment, sir. Okay.
Sir, I already placed it.
Okay, thank you, sir.
Go on.
Thank you,
Because
sir.
you can rush up the things.
Okay.
I already placed it.
Okay. So participants, please, I hope you have gone into the cloud. Okay. I hope you have gone into the cloud. You have created you created a new project. Okay, and inside that, please, in this part you can work. Okay, I am already have given this, so I am going to run one by one. Okay, now in console I am going to clear the console. I have to give Control L. Control L clears the console. Remember, Control L clears the console. Now I am going to install package moments. It is already there. Okay, the package, see here there are some user library packages are available. Okay, user library packages are available here. Okay, I have already installed this moments. It is there. Okay, so if I install either I can run this or I can go here. Let me show you. Since it's online, it's taking time. Okay, if I go here, then I will get a box here. Okay, then there also I can, right from the CRAN, I can install it. So right now I'm using this command. Let me run this. Okay, it takes time since it's in cloud. Okay, so already I have installed this. You can try this in your cloud area. Already I have installed this package moments, and already I have also loaded the package. See, you can see here it is loaded. Moments, it has been loaded. If I remove the tick, it is get detached. Okay, so suppose I want to remove that, I want to detach it. Either I can use this command, okay, or I can remove this tick. See, it is get detached. Now the package is detached. Now I want to load the package. I can click here. Okay, it is get it loaded. Okay, so now first thing is I'm installing the package, which I've already done. I hope you are getting this. I hope you can able to do this in your RStudio Cloud. Then I can load the package. If you load the package, automatically the tick will come here. Okay, or you can go manually and put a tick here and you can detach it. Okay, and as I was discussing there are some predefined packages inside. I will show you that. Those are mass will be there. So see, system library. Okay, in system library you can see mass is there. So there are some inbuilt mass is there, MGCV is there, or all the packages you no need to install because those are system packages. You just load them. Okay, now coming to the next one. If I want to know about the moment, I'm going for a documentation. Either I can run this, or if you want to do it from a keyboard, Control Enter. You give Control Enter. Okay, you keep the cursor on that particular line, give Control Enter, or you can go and click the Run button. See, a documentation for the package is there, which talks about what is the license, what is the date it was published, who are the authors, what is the version, what are different data sets available in this. Okay, so this is one way of using help for and to find what is there inside your package. So your documentation for the package will open. Okay, right now let me create a variable a equal to 5. Okay, I'm creating a variable a equal to 5. I'm calling that variable, it's 5. I'm creating a variable b equal to 6. I'm calling that and I'm going to add those two and put it in C. I'm calling this. Okay. Right, now 11. Now, as I mentioned, if I feel hereafter I no need that A and B, I can remove that. Okay, I have removed that. Now, if I go and call A, it tells object A is not found. That means it has been removed from the memory. Similarly, object B not found. Okay, in this way you can remove the variables which is no longer needed for you. Okay, then coming to help. Okay, so if we are talking about help of LM, I want to know about linear model. If I run this, see here, it has come to the next one. Let me run this first. Okay, see here you can see how to use linear models. What are this parameter? Everything will be given here. Okay, and if you want the manual from HTML browser, I can give help start. See, this is the manual from a HTML browser. And if you want to know about a subject, particular data input, okay, I can run this. See, it talks about how to use data input, create a data input. Then if you want to know about how to use table, question mark the table function name, then it goes and tell me how the tables are created, how cross tables are being done. Okay. Then if I want to know where this my function LM lies, I'm going to use find LM. It tells it is in package called stats, which I was mentioning earlier. And if I want to find where the mean is there, you can see it lies in the base package. Then I was talking about the approps, see, you can see it go and fetches all the string where LM is there. Okay, and I was talking about the demo command. See, here I'm going to discuss about the perspective plot. So I'm giving this, it is asking me to hit return. Okay, I'm just entering this. Okay, and if I enter, see, you can see the plots. If I want, I can increase this one. Okay, then again if I go and type here, okay, so different plots are available. You can see their corresponding code is also there. You can use those and you can find it. Okay, so this is thing. Then similarly there is I will give another example here, colors, which you can explore later. Then if I want to find how to use mean, I'm giving example of this. So see here, it takes example itself 0 to 10, 50 data points. It finds the mean. It trims 10% both side and it finds the mean. Okay, so now how to create a vector. Okay, first I'm creating a vector called apple. I'm calling that again. I can see red, green, blue. Here, if you see here I've given double quotes. Here I've given single quotes to illustrate that it doesn't matter whether you're giving double quotes or single quote. Okay. Now I'm going to create a vector called x, which contains a numeric value. Okay, and let me call that again. Okay. Now I'm going for create a matrix M1 by I want to override the default thing of matrix in R. That is, I'm going to give by row equal to true. So if we call this, you can see the elements are placed row wise. Okay, now if I want to use the conventional method of R, that is placing the values column wise. So this is the corresponding example. Okay, because this you will be deciding when you're dealing with linear algebra, which we'll see later. Okay, similarly, I'm creating a data frame. So gender I'm creating, I'm calling the gender again, then its corresponding height. Okay, then I'm calling the height again, its weight and its corresponding weight. Okay, then age. So now all the variables are created. Okay, now I'm going for BMI. BMI is a data frame, data dot frame. Remember the syntax is data dot frame. Okay, and the corresponding BMI. So now you can see this is the corresponding data frame is created. Okay, so now let me switch back to the PowerPoint presentation. Is it okay? Now we'll go to the next module, how to do descriptive statistics using R. Okay, so now suppose I want to evaluate this expression z equal to summation over I runs from 1 to n xi square. Now for this I'm taking a small data set. Let my x be 2, 3, 4, 5. So I'm going to find this expression for this data set. Okay, so first I'm just getting the input as a vector, then calling that, then sum of x square. If you use sum of x square, then you can find this expression. Okay. Similarly, if I want to find summation xi square minus n x bar square, okay, so this part already we have done. Okay, that is, so first let me get the x value, already we have done that. Now I need the length of x because I need n here, the number of data points in my data set. So I'm giving the length of x. Length of this vector is 4. Then sum x square minus length of x, and we know this is mean. We know it is x bar means mean. So mean of x whole square. So this is the corresponding value. Okay. So this in similar way you can do for any expressions where if you are able to get your values or a data points as a vector. Okay. Now the another important thing is how to deal with missing values. Usually when you take a survey, people always they won't give you the correct data. For example, you're asking about the annual income. Some people they will give, or some people they will just like that they'll leave ignore the corresponding question, or okay. So in such a case, in your data set you'll be having some missing values. So how to deal with this? Because once if you're having in an attribute, I'm talking about a column. If in a column, suppose they didn't 1 or 2% they didn't mention their age, they have given blank, means I cannot find the summary statistics for that. Okay, so I have to clean that. Okay, so here in my data set, here in this example, I'm taking 10, 20, 30, 40, a small data set for you to understand. I'm asking whether there is any NA values. Okay, missing values. It tells false. This thing returns a Boolean result. It gives me whether true or false. In this case, all the values are there, so it gives me false, false, false. Okay. Now on the other hand, let me take one data set like this: 10 NA, so not available value. Okay, not available value. 30, 40 is there. Okay. So now first, in order to do the summary statistics, I want to clean this. Okay. So I'm telling whether here I can easily find there is an NA. You assume you're having a data set with 1000 rows or 500 rows. Okay, usually the people who are doing that commerce and management, or people who are doing questionnaire thing, they used to collect a huge sample size. So let us assume they're having 500 rows, and if some data are missing just like that, we cannot see that. So I have to use this command, is dot na of x. I'm telling whether in this x column or x attribute is there is any missing value. It tells yes, there is a missing value, true. It gives me first one is false, second one is true. Okay, so it tells me there is a missing value. Okay, now how to clean this we will see with the data set later. Now absolute and relative frequency. Okay, now suppose result of 10% declared in two categories: pass, I'm using 1, fail, it is 2. So 10% detail is there. Okay, now I'm going to find the frequency. When I'm talking about frequency, you should remember I have to use the function known as table. Table gives me the frequency. Okay, so first let me key in the values. Result equal to C of, I have keyed the, so 1 is pass, 2 is fail. Okay, then I'm calling result again, then table of result. Okay, table means it gives me the count, so it tells me 6 people have passed this course and 4 have failed this course. Okay, so this is absolute frequency. Suppose I want to find the relative frequency, I have to divide by the length, is it, by the number. So I can say 60% have passed and 40% have failed this. Okay, now let me construct a frequency table. Usually in your statistics class, you'll be considering a frequency table from a data set. The similar thing we will see how we can do using R. Okay, so here I'm having following or the time taken by 20 participants in a race. So this is the data for 20 participants in a race in seconds is given. Okay, now first let me key in the value. So time equal to C of, I'm going to key in the data. Okay, then if I call time, I can find all the 20 values. Is it? Now let me find the range for this data set. Okay, what is range of time? If I give range of time, the minimum of the data set is 32, the maximum of the data is 84. So 32 seconds and 84 seconds. So I have found out the range. So based on this range, I can decide where can interval. So I can start my interval from 30 to 90. Is it? If I go from 30 to 90, all my data will be included. Okay. So now I'm using these are all user defined. So I'm using breaks. I'm going to create a sequence from 30 to 90 by 10, 10. with increment of 10. So if I call the breaks, you can see 30, 40, 50, 60, 70, 80, 90. Okay. Now I'm going to check in which particular thing. First, let me construct the interval. So time underscore cut equal to, so this cut is a command, it is a syntax. So from time and breaks, and I'm going to write right equal to false. So right should be an open interval. Okay. So cut time comma breaks right equal to false, and I'm calling this time underscore cut. See, you can see the intervals are created. Okay, intervals are created. And what is this 30 to 40? Again 30 to 40 comes. No, what it means, this data 32 lies in 30 to 40. This data 35 lies in 30 to 40. This data 45 lies in 40 to 50. Okay, so that's why the levels are 30 to 40, 40 to 50, 50 to 60, and it goes on. Now I want to find the frequency for this. So I have to use table time underscore cut. Okay, if I use that, I can clearly see from 30 to 40 there are 5 persons who fall in this time range. Okay, 40 to 53, 50, it's not including 50. Okay, and 50 to 63, and it goes on. Okay, so this is my frequency. Now if I want that one vertically, then I have to give column bind, C bind, column bind of table of time cut. So here I can view my corresponding class interval and its corresponding frequency. Okay, so this is the way I can construct my frequency table by seeing the data, identifying what is the range for the data, then fixing my interval, and I can use that cut command to create the interval. Okay. Similarly, what is relative frequency? I have to divide by the length of time cut, and this gives me the relative frequency. And if you want to view it vertically, then I have to give column bind. Okay. So now for this, let me go for the bar plot. Okay. So bar plot of table time cut, X label is time, and Y label is frequency. Okay. So see, if I give bar plot of this, I can see this particular bar plot. Okay. So next we'll see another example. Okay. Then so I hope there is no doubt so far. So here we are creating a class interval for a individual data set. Okay, then finding its corresponding frequencies. Okay, then using bar plot, and we are finding the we are trying to visualize the frequencies. Okay, now another important aspect is 3D pie diagram. Okay, 3D pie diagram. Okay, so now for using this 3D pie diagram, you have to install and load Plotrix packages. Okay, so this 3D pie diagram will be more pleasant to visualize rather than going for a 1D pie diagram. So to use 3D pie diagram, I have to install and load a package called Plotrix. Okay, so let me discuss this with one example. There are 3 parallel sessions in a webinar. They are denoted by 1, 2, 3. Let us assume there are 3 parallel sessions going in a webinar. Sessions attended by first 50 participants is recorded as follows. That means the first person has gone to webinar 1, second person has gone to webinar 2, the third person has gone to webinar 2, the first 2 persons have gone to webinar 1, third has gone to 2, and so on for 50. Okay, so now first I am going to key in this. Is it? So let it be the session participants. So I'm going to key in all this data, 50 data. Okay, then I'm making sure how many respondents are there. I'm giving length of SP 50. Okay, once it is there, then I want to segregate how many person went to seminar session 1, how many went to seminar session 2, 3. So I have to go for the table command, table of SP. It gives me the frequency. So 17% they have gone to webinar 1, 19 they have gone to the webinar 2, and 14 webinar 3. Okay, then once the data is there, then I can view this as a pie diagram. So this is the pie diagram, but this doesn't give me any idea what are these colors indicate. So I have to gradually add those toppings for my pie diagram. That is the same thing, pie 3D, table of SP. Okay, so session participants, I'm giving labels SP1, session participant of webinar 1, webinar 2, webinar 3, and main is participants attending parallel sessions, and I'm giving color green, red, blue. If I give this, I will get a pie diagram like this, which indicates so this many people they have gone to webinar 1 series, session 1 in a parallel webinar series. Similarly, exploded plots are there, exploded pie 3D plots are there. You can give just explode in between. Here you can give just explode 0.3, and if you run this, you can see this exploded plots. Okay, exploded plots. So many things you can do in plotting. So many plots are available, which you later after this, if you are interested, you can explore that. Okay. So moving further, now coming back to the time data. So that is a continuous data I'm having. So let me try to go for a histogram. So what is the command hist? HIST is the command. Time data breaks 5 column equal to red. Okay. So if I give, I will get this histogram. Okay. So then let us find some basic descriptive statistics like arithmetic mean. So mean of time will give you the arithmetic mean, and geometric mean, you know, the nth root of xn x to xn. So there is product of time, because we are going to multiply all the data points, then power 1 by n, or 1 by the length of time. Okay, length of time is it. So it is 53.49774, and harmonic mean is 1 by mean of 1 by, you know that, is it. So these three means are quite different. This is a linear mean. When you're going to use geometric mean, when you're having a proportional data, you'll be using geometric mean. When you're having kilometer per hour, per second, per minute, something data like that, you'll be using harmonic mean. Okay, so this is the thing to find the basic statistics. And similarly, you can find the variance. If you give VAR of time, you will get the variance for the data. And you know, the standard deviation is the positive square root of variance. So SQRT of variance of time will give you the standard deviation. And IQR is interquartile range, that is Q3 minus Q1. Okay, so you can just give IQR, it finds what is Q3, what is Q1, then it gives you the answer. Then if it is IQR by 2, you know this is the quartile deviation. So these are some basic descriptive statistics which you can easily find once you have a data set. Okay, and of course, if you give summary, you are going to get everything, which we'll see later. Okay, so now then I want to view the PMF. It is given as PDF, no issues. PMF and CDF of a rolling a die. Okay, so now let us try to visualize this. I'm going to visualize how my PMF is going to be and how my CDF is going to be. Okay, so this is my data. My random variable takes values 1, 2, 3, 4, 5, 6, and its corresponding probabilities are 1 by 6, because they are equally likely. 1 by 6, 1 by 6, 1 by 6, 1 by 6, and its cumulative probability, I'm going to cumulatively add this. This is P of x less than or equal to x, is it? So 1 by 6, 2 by 6, finally I'm ending up in 1. Okay, so now how to visualize this? So first let me put the probability as PROB, repeat, because all the values are repeated, is it? I'm using repetition of 1 by 6. How many times? 6 times. Okay, you can always ignore this warning. Okay, so if there is warning, no issues, ignore that. Okay, and once you call this probability, you will get the probability of all the items, and they're equally likely. No, they are all are same. Okay, so I have found out what is probability using the data which is given here. Okay, right. Now let us plot that. So plotting probability, type equal to H. So I want a histogram plot. Okay, if I use L, it gives me a time line plot. If I use S, it gives me a step plot. Okay, I'm using H here, and these are things which we are giving to enhance the readability of the diagram. Okay, what is main? Main is probability distribution. X label is outcomes, all those. Okay, so now using this, I've created a probability distribution plot which talks about the probability mass function. I have plotted that. Okay, now let me find the CDF, how it's going to be. So I have to find the cumulative value. So cumulative probability equal to cum sum. The syntax is cum sum of probability. Okay, because my probability I have stored in the variable called prob. So cum sum of that prob. So I can see the cumulative, these are the values, and it will finally it will end in 1. Okay, 1. Now to plot this, I have to use this particular cum probability type H, and these are the things which are giving to for the readability, and I can see it starts there and gradually it reaches 1. So this is the cumulative probability distribution which we have visualized. Okay, so now can we do it for a two-dimensional random variable? Okay, yes. So I have given an example here where my y takes values 0, 1, 2, 3, x takes values 0, 1, 2, 3, and these are the corresponding probabilities is given. Now let me first key in all the values. So I'm going to key in this and I'm going to take it as a matrix. So P row equal to matrix of C of, I'm directly giving this value 0, 1 by 4, all this. How many rows? I am having 4 row. How many column? I am having 4 column. I need the values row wise, so I have to give by row equal to T. Then if I call this, I am getting this particular matrix. Okay. Now, I'm going to use scatter 3D plot. This is called scatter 3D plot. So I'm going to install and load a package called scatter 3D plot. So this particular package has to be installed and it has to be loaded. Okay. Then I'm giving the possible x value of x. As I mentioned, x can take values 0, 1, 2, 3. Similarly, y can take values 0, 1, 2, 3, and its corresponding combinations 0, 0, 0, 1, 0, 2, 0, 3, all I'm giving here as C1, C2. Then I'm going for a data frame because scatter 3D plots works on the data frame. Let it be S3D.dat data.frame. My column C1, row C2, where to fetch the value? Fetch the value as a vector from P underscore row. Okay, random variable. So once this is there, then I can use scatter 3D plot and I can plot this. Type is histogram and line width, the pitch. It talks about the head of the nail pitch and what should be the joint PMF. Okay, see here you can see a surface. Is it? If I cover with a paper on the top of all the pins, I'm going to get a surface which because x comma y is two-dimensional random variable, obviously it is a surface. Okay, it is a surface. Okay, so this is the way. In this way, you can construct the you can visualize the PMF and joint PMF. Okay, now I thought we'll talk about something about linear algebra because which is a very important aspect in data analysis and data analytics. Because in a data in any data set, each column is seen as a vector. Suppose I'm talking about the age, that is a vector. I'm talking about gender, again it is a vector. So everything we are going to visualize as a vector. So definitely linear algebra plays an important part in data analysis and analytics. Okay, now let us see how this can be done using linear algebra can be done using R. So for doing linear algebra, you have to install and include package known as Pragma. Okay, you have to install the package and include the package called Pragma. Okay, once it is installed and loaded, then you can perform these things. So first thing, let me try to find the rank of a matrix. So I'm going to key in the matrix 1, 2, -1, 0, 0, 1, 3, 1. Okay, so it's 3 row 4 column matrix. I'm giving this n rows, n columns by row equal to T. So I need everything in terms of rows. So now this is my required matrix. If I give rank of A, it gives me the rank as 3. That means after the row reduced echelon form, I'll be having 3 independent rows, and that is my rank. Rank is 3. Okay. So directly you can give the matrix, and once you call rank of A, it gives you the rank 3. Now, how to check whether your vectors are linear independent or dependent? For example, here I've taken one example. I've taken this example from the standard books which you people are following. Okay, that is consider the vectors 1, 2, -1, 0, 1, 3, 1, 2, 4, 2, 1, 0, and 6, 1, 1, 0, 1, whether it is linearly independent or not. So each vector will be my column, and I'm going to find the determinant of that. If the determinant is not equal to 0, then I can say they are linearly independent. If it is 0, then they are linearly dependent. Is it? So now my aim is to get all these vectors column wise because I need the vectors to be as a column wise. So I'm going to key in A equal to matrix C of this values, n row 4, n column 4. I'm not going to give anything here because by default it is going to place all my data column wise. So this is my first vector, this is my second vector, third one, and fourth one. I have stored it in a variable called a. I find determinant of a, it is 55. Then I'm writing a code. If else determinant of a equal to 0, the vectors are linearly dependent. This implies else the vectors are linearly independent, and in this case the vectors are linearly independent since determinant a is not equal to 0. Now to do consistency and inconsistency of a system of linear non-homogeneous equation, we should install and load the package called matlib. Okay, remember you're going to install and load the package called matlib. So here I've taken two examples, one for consistency, another one for inconsistency. Test for the consistency of this system and find the solution if it exists. Okay, I'm going to find whether the system is consistent, and if so, I'm going to solve it. So first I'm going to get the coefficient matrix. You know the coefficient matrix is 1 minus 1 2, 2 1 4, 4 minus 1 1. So this is my coefficient matrix. I'm getting that matrix. Okay, I need in terms of row, so I'm writing by row equal to t, and if I call that, I'm getting this matrix. Okay, then I need the right hand side constants. So b equal to matrix of 2 7 4. I didn't mention anything here, so obviously it will be placed in a column wise. It is in a column. Okay, now I'm going to see the equation. Okay, so equation clearly says it's x minus here, since it is xyz, I'm using x1 x2 here. So x1 minus x2 plus 2 x3 equal to 2. So this is the set of equations which is there. Here it is in terms of xyz, but here it is in terms of x1 x2 x3. Now once it is there, then how you will find the consistency? You'll be finding the rank of a, and you'll be finding the rank of the augmented matrix, and if both are same, then I can say, and it is equal to number of the unknowns, then I can say it is consistent. Okay, I'm not going for less than number of unknowns. I've just taken an example here. Okay, so where the rank of a is 3 and comma the rank of C bind of AB, I'm combining this AB means it is the augmented matrix AB. So rank of A, rank of B, I'm just comparing both 3 3. So if else rank of A equal to rank of C bind of AB, then the system is consistent. Otherwise the system is inconsistent. So in this case it happens to be 3 3. So the system is consistent. Since it is consistent, I can solve it. Okay, solve a comma b, fractions equal to t. So I'll get x1 equal to 1, x2 equal to 2, 1, x3 equal to 1. So I have taken one example where it is consistent. Okay, and if I plot that particular equation, is it this equation, I can see three planes, and they meet at a particular point. That point is 1 1 1. Okay, so that is 1 1 1. Okay, I have plotted that equation 3D. Okay, now in another example which I've taken here, x plus 2y minus 3z equal to 3, 2x plus y plus 4z equal to 1, 5x plus 4 plus y 4y plus 5z equal to 2. Okay, now the same thing, first key in the coefficient matrix, this one, then key in the right hand side constants 3 1 2, then again show this as an equation. Then I'm finding the C of R of A and the rank of the augmented matrix AB, and I can clearly see my rank of A is 2, my rank of augmented matrix is 3, so the system is inconsistent. And if I try to solve this, I will get one observed value like the 0 equal to 3 by 2 that clearly shows that the system is inconsistent. And in this figure, if you see that, you can see there won't be any common point for these three planes, which implies they are inconsistent. Okay, which I will show you while we are doing the answer. Okay, now coming to the eigenvalues and eigenvectors. Okay, so and suppose I'm giving a matrix A is given, so I'm just going to key in, okay, using n rows, n columns by row equal to true, and so this is my corresponding matrix. If I want to if you want to find the eigenvalue, you just give eigen of A. Okay, so you can clearly see the eigenvalues are 3, 2, -1, and the corresponding eigenvectors are here. Okay, so just give eigen of A, it will give you both the eigenvalue and the corresponding eigenvector. Okay, now if you want to find the inverse of this matrix, I and B of A will give you the inverse, and to show that A into A inverse equal to I've just taken this to verify that A percentage star percentage is the matrix multiplication. Okay, so A inverse, you can see 1 1 1 and all these values are 0, minus is minus 0.000, so nearly 0. Okay, so this is the thing, this is the corresponding code to find the eigenvalues and eigenvectors. Okay, now coming to null space. Okay, if we ask you to find the null space, so I'm here I've taken one example, the matrix A. This is the matrix that is 3 -2 -5 -1 2 3. For this I'm going to find the null space. What is the corresponding B? What is null space? The solution for Ax equal to 0, the set of all solutions for Ax equal to 0 is the null space, is it? So my B is 0 0 0, so which is there. Then I'm going for row reduced echelon form, RREF. If you use RREF of A, it gives the row reduced echelon form, and you can clearly see here this variable, that is x1, x2, and x4. These are the pivotal variables, is it? These are the pivotal variables. So your free variables are x3 and x5. So all the variables you are going to represent this in terms of this free variables, is it? So if you write this as an equation, it will be like this. Okay, then see x1, x2, x4 are pivotal variables, x3, x5 are free variables. So the vector x can be represented as x3 plus x5, and these two vectors are said to span the entire null space. Okay, and every element of the space is spanned by these two vectors. Okay, so in such a way I can use R to find the null space, which will be very useful when you're dealing with data analytics. Okay, now I will switch to RStudio Cloud. Okay, and then I will do all the commands. So I think I can go to the RStudio Cloud. Okay, so I have gone to RStudio. No issue, you do it in RStudio Cloud, because I want to show you the figures. Those figures is not popping up in cloud, so I will do it here. The same thing you can do. Only thing is, in RStudio Cloud you won't get the figures. I want to show you the figures for that consistency, so I have opted for RStudio, which I have loaded in my PC. Okay, so no, I think there will be no issues. You can easily do that. Now let me start from this. Okay, I think so let me create X. So we are going to do an hands-on session for the module 2. So I'm going to execute this X. Okay, I'm going to call that again. Then I'm going for finding Z. As I mentioned, I need summation X square. Okay, then again I'm creating a value X. I'm finding the length of it. Okay, then going for expression n x bar whole square, summation x square minus n x bar whole square. Okay, then now coming to the missing values. I'm a little bit fast because so many things to cover, so please bear with me. X is dot na, I'm telling it tells false, 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 which I have discussed in the slide. Okay, then a data set with a missing value is dot na. I'm asking, yes, it tells the second data is a missing data, it gives me true. Then we discussed the pass fail of 10 candidates. Okay, I'm going for this. I'm trying to find the frequency. Okay, frequency is 6 have passed and 4 have failed, and this gives me the relative frequency. Okay, then we discussed about how to construct a frequency table. I will show you that quickly. Okay, I hope you're having the code with you. You can copy that, you can run line by line quickly. Okay, time, I'm calling the time again. Okay, then I'm finding the range for the data. So it's 30 to 84. Then I'm going to break using, I'm going to create a sequence. Okay, and the sequence is from 30 to 90. Then I'm using cut. I'm going to construct the class intervals like this. Then if I want to know the frequency in each class interval, I'm going to use table of time cut. It tells me 5, 3, 3, 5, 2, 2. Okay. Then if I want to visualize vertically, I use to column bind. Okay. Then if you want to go for the relative frequency, I would divide by the length of time cut, and it's there. Then if I want to view this vertically, then I'm using cbind. Okay. Now let me go for the bar plot of this time cut. Okay. So this is the corresponding bar plot, and since I have joined here histogram also, because the time data, going for histogram for the time data. Then the basic discrete statistics like mean, I can find geometric mean, I can find here harmonic mean, it is here. Okay. Then I want to find the variance for time and the standard deviation, the positive square root of variance, and the interquartile range Q3 minus Q1. Okay, it is 27, and quartile deviation by 2. Okay, so this is a thing. Now since I'm let me use plot trick, because I'm going to use 3D plots. Okay, let me run this.
So that is 1 by differential equation in the right hand side function. That is equal.
Okay, then I'm going for it is installed. I am loading that. Now it is ready. I'm running the parallel session problem. Okay, let me find the length of it. I know I said 50 respondents were taken, and I'm finding the table. So parallel session 1, 2, 3. How many of you they went for the session? Okay, and I'm going for a pi 3D chart. Okay, then if you want to add labels to it, I'm doing it here. Okay, okay, and this command, this hash, it is this tells me this will not be executed by your compiler. Okay, R compiler. So this is command. If you want to command anything, you can give this hash, then you can write things here. Okay, then if I want to go for an explored pi d 3D chart, okay, this is exploded one. Now coming to how to visualize the your PMF and join PMF, we already discussed that. I took a coin tossing problem, sorry, a dice, rolling a die problem. Okay, and this is the corresponding probability, and let me try to plot that. Okay, see, this is the plot. Okay, then I want to plot the cumulative distribution function. For that, I'm finding this cumulative probability, that's come sum of probability. So you can see this is the cumulative probability that gives me the probability 1, and I'm trying to plot that cumulative probability. Okay, and if you can see, it is gradually it reaches 1. Okay, now to visualize the 2-dimensional random variable, I need scatter 3D plot. So now let me run this. Okay, it is getting installed. See, it is getting installed. So it directly goes, since I'm connected to the net, it goes there and it fetches, and it is getting installed. Okay, once it is installed now, then let me load the package. That is important. I have loaded the package. Now it is ready for me to do the analysis. Then I'm keying all the corresponding probabilities for that bivariate data. Okay, then I am just visualizing that probability values. Then I'm defining what are the possible x value x can take, possible value y can take, random variable y can take, and its various combinations C1, C2. Then I'm creating a data frame. Okay, and I'm going to fetch the data as a vector from P row. Okay, because I want to draw those lines, is it? So in form of vector. Okay, so then I'm visualizing the scatter 3D plot. You can see this is the plot. Okay, so these are all the pin heads. If you put some other value of, for example, if I'm putting instead of 12, if I put 15, okay, if I run that, your pin head will be some other figure. That's it. Okay, it all depends on the thing. So all these things you can easily explore. This is the line width. Okay, everything. Okay, now let us do the linear algebra part. Okay, so for that, as I mentioned, I'm going to install the package called Pragma. Okay, so Pragma, it is getting installed. Okay, okay, it is getting installed. Now I'm going to load that package. Package is loaded. Now it is ready. So first example, I found out the rank for this particular matrix. So rank is 3. Okay. Then going for linear dependence and independence of vectors. This is my first vector. So I'm going to key in as a matrix. I'm calling the matrix again. Okay. And all these, the columns represents the vectors. And I'm going to find what is determinant of it. It's 55. And I'm writing the code so that whether it is independent or not using if else. So the vectors are linearly independent. Okay. Then I want to install a package called matlib to do consistency inconsistency. So I'm loading that matlib package. So all the things you can do in cloud also. The only thing is I'm not getting the figure there due to some issue. Okay, because it will pop up as a separate window. Okay. So now let me load that. Okay, and this is the corresponding coefficient matrix. Okay, the corresponding vector right hand side by vector B. Okay, then I'm showing it as an equation. Okay, then I'm finding the rank of the matrix, coefficient matrix and the augmented matrix. Both are 3, 3. Then I'm writing a code to tell that it is consistent. Once it is consistent, I can solve it, and my values are 1, 1, 1, and I'm trying to plot it. So can you see this thing? Can you, sir? Danshay sir, can you see this?
Yes, sir. Yes, sir.
Okay.
Previously it came.
This one, sir?
Yeah. Yes, sir. Yes, sir.
So here I can rotate this. I can see there will be a common point for all the 3 plane. So that is going to be my my solution. Okay. Similarly, for the next example, I've taken another example to show the inconsistency. Okay, which is there. Then this is the coefficient matrix. This is the right hand side. Then I'm viewing it as an equation and trying to find the rank of A and rank of AB. And in this case is 2 and 3. So clearly it is inconsistent. And if I try to solve it, I will get an observed value 0 equal to 3 by 2. Okay. Then if I plot this, I will get a pop-up window now. I think you can see this. See, you can see this one. There's no common region. You can see this between the planes. Okay. There's no common area. So obviously it is inconsistent. Okay. Now finding the eigenvalues, eigenvectors. It is A. Okay. Then I'm finding the eigenvalue. Then I'm finding the inverse. Then to check whether my inverse is correct, A into A inverse, I'm getting I. Okay. And for finding the null space, I have taken one example. This is the matrix of which I'm talking about, which I want to find the null space of this. Ax equal to 0. Okay. And this is the corresponding matrix. And my matrix B is 0, 0, 0. Okay. And RREF means I'm doing for row reduced echelon form of A, and it clearly tells me this one, x1, x2, and x4. These 3 are the pivotal variables, and obviously x3, x5 are the free variables. So using these free variables, the entire variables x1, x2, x3, x4 can be written as these 2 variables. So null space is spanned by these 2 vectors. Okay. So I think I might have been a little bit fast. Now let me go back to my slides. So we are in the third part, very important part, that is, okay, all this I'm going to skip. These are all easy things. What is analytics, what is data level, okay, all this. Okay, so now coming here, now my next thing is how to import a data set. That is very important. How to import a data set. Suppose you have done a survey, you're having some data set outside, okay, and you want to bring the data set inside our studio, and you have to work on that. Okay, so how to do that? So here 2 ways are there. So if suppose my data set is in this particular inside this webinar, for example, my file is inside this webinar, I can give the path location and set that path location as the work directory. Okay, this is one way of doing it. Okay, and once it is ready, once the path is ready, I can write read.csv. Remember, I am going to import a data file. The data file can be in a form of .csv, comma separated value. It can, once you after the survey, you'll be having an Excel file. If you're doing a survey using Google form, you'll get an Excel file. Excel file you convert into .csv file. You change it to .csv file. You might ask, why sir, can't I work with Excel file? Definitely you can do. I will tell that later. So here I'm going to change it as a .csv file. Once that file is there inside my working directory, then I can write df1. I'm giving a variable data frame 1 read.csv payment details.csv. So this is my file name, which in the form of a .csv file. I am just calling that, I'm loading that, and I give df1. I'll be getting this data. Okay, this data. So remember, one file is there in my desktop under a particular folder. I have to give the address for this folder. So how can you do that? You go to the particular file, right click that, go to the property, go to the location. You can find that, copy that, paste it here. There will be having the backward slash, convert into forward slashes. Okay, and give the path location. It's very simple, easily you can do. Okay, otherwise in cloud how to do, I will tell you. Okay, so now how to import Excel file. For importing Excel file, you should need a package called read Excel. Okay, you have to install this and load this package, then you can import Excel file. That is, for importing Excel file, remember read underscore. For CSV it is dot, for Excel underscore read underscore Excel payment details dot Excel. Suppose I'm having my payment details in Excel as, I think I have sent both the files. I have sent both the files to Angeline ma'am. Okay, so ma'am, she might have sent you those files. Both the files are there. .csv file is also there, .xls file is also there. Okay, and if I call df2, you will get the corresponding data set is imported inside. Okay, now data cleaning. If you see, I'm going to use the .csv file. I'm going to use this .csv file. Okay, I'm not going to use Excel file. I'm going to use this. If you see this, there are some NA values in between, NA, NAN. Okay, then small NA is there, N/A is there, and missing values are there. The first thing is you have to clean this data set for further analysis. Okay, you have to clean this. So to clean this, the important package is tidyverse. We have to load a package called tidyverse. Okay, which contains the best collection of R packages for data science, which is exclusively used for data cleaning. Because once you clean your data, 80% of your work is done. So, and easily you can do the other statistics. Okay, so cleaning is very important. Okay, so you have to include tidyverse and load that package tidyverse. Okay, now I want to have a glimpse of my data set. Okay, so give glimpse df1. See, you can clearly see all are factor variables or character variables. Only one is double type. Monthly charges is double type. Okay, all others are factor character variable. FCT means factor character variable. DB1 means is a double type. Okay, so this is numeric. These are all in the form of characters, factor characters. Okay, so now I want to change all these NA, NAN to some values. Usually what they will do is they will either use mean, median, mode. Okay, that means they will find the mean of the entire data set, leaving this NAs, and using that value they will populate the missing values. Okay, so they are going to populate the missing values. Either you can use mean or median. Okay, or mode also it is used. The other way is you have to create a two data set. One is with missing values, another one without missing value. You have to construct a linear regression, and then using that you have to populate the values. Okay, so here we are talking about a simple way finding the median. I have used median here, is finding the median of the data set, leaving the NA values, and take that value and populate the missing cells. Okay, so we are going to do that. So now first thing is, in my data set, remember my data set is stored in df1, and in df1 I am having customer ID as one attribute, monthly charges as another attribute, total charge as the third attribute, payment method as the fourth attribute, and whether they will continue with us or the fifth attribute. Okay, so now I want to access. I'm not going to touch the customer ID because customer ID is there already there. Only second attribute as some missing values. So I'm going to start from the second one. So I want to access my monthly charges column alone. In a big data set, if you want to access only one attribute, what is the command? df1 is your data set where the entire columns are there. Dollar symbol monthly charges. So if I do this, what it implies, I am going to the df1, I am going to only fetch monthly charges column alone. I am going to remove monthly charges column alone outside for my analysis. So remember, it is dollar. So df1 is my entire data set, dollar monthly charges. And what I said, I have to check whether is there is any NA values in that. Okay, before finding the summary statistics, I have to make sure there is no NA or NAN or N bar A, whatever it is values. I have to clear it. So is dot NA df1 dollar monthly charges. Okay, if you want, you can store this in one variable and you can give this. It's left to you. It's left to the programmer. Okay. So here, if I go for df1, see, I'm able to cater only the monthly charge column. Here I have taken a small data set with only 10 entries for us to easily understand. Okay, so I have fetched only the monthly charges thing, and I'm telling whether there is NA. Yes, it tells yes, NA is there, not available value, true. It gives me true. NA also it tells me true, because this is dot NA fetches NA value as well as NAN. What is an NAN? Not a number. It is not a number. So NA and NA both are fetched by this is.NA. So I can clearly see there are three values which is missing. Okay, and this is a small notice there. Instead of this braces, I'm going to use this pipe operator. No need to worry about that. Okay. So now from DF1, from DF1, let me go to DF3. I used instead of DF2. Okay, DF3. So in DF1, I am going to use a function called mutate. Okay, I am going to replace wherever there is NA, I am going to replace it with the median by removing NA. See the last one. Replace monthly charge, comma, wherever there is NA with what? Find the median of this monthly charge, removing that NA values. So wherever there is NA, I am going to replace with the median by removing the NA value. Okay. So this, all the missing values, NA values, will be replaced by the median of the remaining data points in that attribute. See, I've used this and clearly see there's no NA. It has been replaced by the median of that remaining data. Okay, so this I have completed. So remember, if previously there was some NA value, I have now changed it to all. I'm having a numeric value. Now if I go for a summary statistics, I can find minimum, maximum, all this I will get. Okay, now coming to total charge. In a similar way, I have to fetch first total charge outside, but there is an issue here. Since total charge, payment method, all are factor character variable, first I have to change them to a numeric variable, and then only I can do the process. Okay, initially I showed only double it is a numeric data, so directly I was able to do it, but here these are all factor character variable, so I have to change this and then only I can do this. Okay, now already DF3. Now what is the updated database name? DF3. Update database is DF3. So now from DF3 I am going to fetch total charges. Okay, so DF3 dollar total charges. So it fetches the total charges column from DF3, and I'm going to find whether there is any NA data in that. If I run this, it tells yes, there is one. Okay, this NA is ignored. Okay, this NA alone it is being fetched. This NA is also ignored. Okay, but I can clearly see N bar A and small NA is there, so I have to replace everything by the median of this data set. Okay, so let it be DF4. So mutate total charges. Okay, and I'm going to replace NA small NA. Okay, with the capital NA, because all the things small NA, capital NA, N bar A, everything has to be replaced first by NA. First I'm going to bring it in the same thing, NA, is it? So this DF4 is an intermediate table which converts all small NA or N bar A to NA. Okay, once this is ready, so you can see here Now all are NA. Now, since as I mentioned, it is a character thing, I'm going to convert this into a numeric data. Okay. Once it is converted in numeric data, then I can see this is the process of converting the character to a numeric value. And this symbol, I think I didn't mention about this. Instead of this symbol, you can also use equal to. Both this arrow symbol, that means this side is assigned into this side, or very similar to our equal to. You can either use this arrow, or I can also use equal to. Both are one and the same. So if I do this, my intermediate table is now, what happens? The value is still NA is there, but the character, the type that has been changed from factor character to a double type. Okay, now from factor character it has been converted to a double type. Okay, now again using the mutate function, I mutate the finding the median by total charge by replacing the missing values, and then I'm going to populate with this median. That is what done here. See, you can clearly see now all NAs are now numbers. And remember, this is now a double type. It is not a factor character type. Okay. So now I have cleared 2 columns successfully. In 2 columns, whatever NA or NAN or N bar A, I am able to clear it. Now coming to the third one, the fourth column. Fourth column is just a character column. So some data are missing here. So I'm going to replace by none. For me to understand that there is a missing value, I am going to use only none. Okay. So that is in this D. So now my DF5 is my current data frame. In that, I'm going to mutate payment method with only none. Wherever that is blank, I'm going to replace by none. So I will get this one. So now I'm having a perfectly good data set where there is no missing values in between. Now I can directly go and find the summary statistics. If I find the summary statistics, it clearly tells me the first column, it is an ID. So it is character column. It tells there are only 10, length is 10. Monthly charges is a numeric data. So it tells me what is the minimum of the data set, what is the first quartile, Q1 of the data set, what is the median of the data set, what is the mean of the data set, what is the third quartile of the data set, and what is the maximum. It gives all my basic descriptive statistics here. Okay. Similarly, the third column is also a numeric data. So it gives me the similar data, the similar thing for that column. And my fourth and fifth columns are characters. So it tells there are characters, the length is 10. Okay. So this is the way to clean your data set. Now let us quickly move to the R cloud. Okay. And try to execute this. Since it is idle for some time, it is getting thing. So sir, is there any issue so far? Am I fast?
No, sir. You can go on.
Okay. Ma'am, Angeline, ma'am, can I take another till 1 o'clock? Angeline, ma'am.
Yes, sir.
Okay.
Yes, sir. You can take.
Okay. Thank you, ma'am. Thank you. Because otherwise, it won't be complete. Let me quickly do it. Okay. So as I mentioned earlier, either I can go and fetch. So these commands, the command, these two, if it is there in your local drive, this is the command to fetch the data set. But what I have done here is already I have uploaded. See, in cloud, you can go here and upload the data sets inside. You can upload the data set inside. Okay, it is inside my cloud, so no need to go and use this command. So these two commands are used when you are working offline. Okay, offline in the sense you are having the R Studio in your PC or in your PC. So this command you can use. Otherwise, you can directly put this in the project inside this, and you can work. So right now I'm going to use this. Already it is there. I'm just going to call this. Okay, and once again I'm calling this. See, my data set is here. Okay, now if you want to read Excel file, you have to okay. So I have to, as I mentioned, I have to include that package called read Excel. Then let me load that package read Excel. Suppose if you want to use Excel file, okay, then df2 Yep. I think it is getting installed. No, see, so this is the file, the same file in the Excel. So I'm having two files. One is .csv file. Hello, sir. Another one is .xlsx file. So first time I imported this. Okay, we are going to use only this. Second time I have used the Excel file. Okay, so this is the way to import the Excel file. Then since I was talking about the tidyverse, which is used for data cleaning, I am going to install that tidyverse package. The issue is it has so many sub packages inside, so everything it has to be it has to get installed. It will take some time because it is a package which contains many packages inside. Okay, so I think let me check in the packages whether it has been there. Tidyverse, where is this tidy? It is there. Okay, it is already loaded also. Okay, right. Now I'm going for glimpse of df1. See, so here I can see one is double, another one is character. Okay, character. Now I'm trying to fetch only the monthly charge from df1, that column alone. I have fetched that column alone, and I want to check whether there is any anomaly values inside. Okay, and it tells me yes, there are some values true. So I'm going to use mutate function, and I'm going to replace it. And if I find df3, now my df3, see, I have changed this. I have found the median of the missing data, and I have populated this using that median. Okay, now let me go to the next one. Total charges. I'm going to fetch total charges column. Here also there is NA, small na is there, n bar a is there. So let me try to replace everything by first NA. Okay, using this command. Now it is NA. Now since it is a character variable, first I have to convert it into a numeric variable. Okay. Yes. Okay, so now this is not a character variable, now it is a double variable. Okay, then I'm going for mutating that to populate the missing values. Okay, now see, it has been populated by the median of this data. Okay, then for the missing value, I'm just going to replace by none. Okay, then so now my DFS6 is there, and my summary, if I go for the summary, then it clearly shows these are my data which I already mentioned. Okay, now let me go to the second part where I'm going to take a file, another file. Okay, so now let us perform some display strategies using R. There is a file called health_data.csv. I have sent this file across to you people, I think so, through the coordinators. But there's some small difference I have made in the file. No issue, you can use that file. But right now we will see that I'm using this file. Okay, so now the same thing, since I have stored that in the inside the project in cloud, I can directly call this .csv, and once my data is ready, see, I've taken just a small screenshot. So this data health data.csv contains 50 rows. So it is a questionnaire taken from 50 respondents. Okay, it considers their age, their gender, whether they exercise or not. Okay, whether their height, what is their height, weight, what is the BMI, BMR, and what is the whether they're married or not. Okay, so now here if you see, these data are categorical data, either male or female, category, only category. Here whether they exercise or not, I've just included yes, no. I can put yes, no, or sometimes. So 3 categories can be there, but here in this data set I'm having whether they exercise or not, and male or female. So these two are called categorical variables. Okay, so once you have a categorical variable, you can do a non-parametric test for this. That is usually what is the best non-parametric test? We know it is the chi-square test. We can perform chi-square test on this. Okay, so now as we have seen, okay, so now I've taken a set which there is no missing values, no anomalies data. So I'm not doing the cleaning part here. Directly I'm going for the summary statistics. Okay, summary of my data, because I stored this in my data. So I'm getting the summary of this. All this is there. Okay. Then if I want to fetch the element in second row, fifth column, I can use my data square bracket 2,5. If I want to use the row heading and column heading to fetch a value, I can use this. This denotes the fourth row, and this denotes the corresponding uh, weight in that particular cell. It fetches me that cell. Now, if I want to know how many rows, I can give n row for my data. It tells there are 50 rows, so 50 respondents are there. If you want to know how many attributes there in my data set, n column my data, there are 9 attributes starting from the ID number. Okay. Then, if I want to fetch second row for all columns, 2 comma blank, that fetches second row for all the columns. And if you want to fetch the fifth column for all the rows, this is the corresponding data. Okay. So these are the some things which I can do manipulate with my data set. Okay. Then, as Darshan sir was last class, we were mentioning about the box plot. I am trying to find the box plot of my weight from my data. So my data is my data set name. In that, I'm going to fetch only the weight. So dollar symbol horizontal equal to T. I need a horizontal box plot. And clearly, as sir was mentioning in the last class, you can see this is one outlier. Okay, the outlier is here. These are the whiskers of the plot. This is your Q1. This is your Q3. This is your Q2. Okay, so this is the minimum of that box plot. So it is nothing but Q1 minus, okay, it is 1.5 times IQR. Okay, it is Q1 minus 1.5 times IQR will give you this. Q3 plus 1.5 times IQR will give you this maximum value. Okay, what is IQR? Interquartile range. Okay, and clearly see in this weight there is one outlier. So this data doesn't fall in under this. It is the outlier. And Sarah has mentioned what is the disadvantage. Mean is not there in that box plot. Okay, then from my data, see I have how to fetch the outlier. I need the weight outlier. So box plot of my data weight dollar out. And if I call that again, I can find what is the corresponding outlier. Okay, then I'm going to find the interquartile range for my weight. Okay, then I'm going to find the moments for my weight. Okay, you know, if I find the moments, I'm going to talk about mu naught. Mu naught is always 1. Is it? E of x power 0, it's E of 1, that is 1. Mu 1, I'm talking about central moment. Mu 1 will be always 0. Why? Because summation x minus x bar will be in the numerator. So the sum of each data point minus its mean will be always 0. So see, this value is always 0 because it is 10 to the power minus 15. I have to go 15 times this side, so it's nearly 0. So mu naught, mu 1, this is mu 2 value, mu 3 value, and mu 4 value. So these are all my central moments. Why it is central moment? Because inside the code I have mentioned to be central equal to T. If I mention false, means I will get the raw moment. So what is the command? All dot moments. What is the data? My data is my weight data. I need up to 4. Order dot maximum equal to 4, and it is central moment. Okay, so it gives me all the moments. Now from my data set, I am going to change male female to 0, male to 1. Okay, by using this factor of my data gender, I am going to change the labels. 0 means female, male to 1. And if I call my data, see now this male female, it has been changed to ones and zeros. Once this is ready, I can go here and segregate only male data, segregate only female data. Suppose I need only the male data equal to subset of my data. This is the main source where I'm having data. And what I have to do? My data gender equal to 1. If I run this and call this again, see, only male data will be displayed. Only male data will be displayed. Similarly, if I want to only have the female data, I'm going for a subset of my data dollar gender equal to 0, and I'm calling my data. So this gives me only the female data. Okay, So now, usually we found out the quantiles Q1, Q3 either using formula, or I can use a syntax called quantile. Quantile of, suppose I want to find the quartiles for my age. So quantile of my data $age. So if I run this, it gives me all the quantiles: 0%, 25%, 50%, 75%, 100. If I specifically need Q1, if I specifically need Q2, if I specifically need Q3, means I have to mention here 0.25. This is nothing but the Q1 data. 0.5 means is my Q2 or the median. 0.75 is my Q3. Okay. So in this way, I can specifically take my Q1, Q2 or Q3. Then coming to table of table 1, for gender, I'm going to find the frequency, because gender has some category. Male, female is there. So I can find the count frequency. Okay. So table of my data $gender. I can see it is a fairly male 25, female are there, 25 male are there. Okay. Then how to consider 2x2 table, because I'm going to consider a contingency table and I'm going to perform chi-square test. So what are the two attributes here? Let me check whether the gender and the exercise, they are independent or not. Okay. So I'm going to construct a table. Let it be table 2, table of my data $gender, my data $exercise. So I'm going to construct a table for these two attributes. So table to see, I can see a 2x2 contingency table. Now I can perform my chi-square test on this. Okay. And if I perform the chi-square test, I can see my p-value is greater than 0.05. So I conclude that the gender and exercise attributes are independent. Okay. Attributes are independent. Okay. Similarly, you can find the correlation between weight and height. Okay. Then you can find the corresponding regression model of your weight and height. Okay. And you can plot that. You can plot that. I will tell you all this when we go to hands-on, because I'm only 10 minutes more. I will go to hands-on. Okay. Then this is the corresponding data sets, and this is my fitted line. Okay. Okay. Then we'll discuss about the summary, and for multiple regression, these packages are to be included, CAR and RGL. Okay. Then I'm going to find BMI is related to, BMI is my data is based on height and weight. So my multiple regression is there, and multiple regression, you can see this is the corresponding, since I'm talking about regression plane, this is a plane and these are the data points. Okay. And let me explain this using RCloud so that I can quickly finish it off. I think so. Coming inside this, already we are having this data. Directly I will go to this health data, run my data. So this is my data, and I find the summary statistics of this, which we already discussed. Since I want 2,5, the element in second row, fifth column, using the corresponding row and column heading, number of data sets 50, number of attributes 9. If I want the second row for all the columns, this is the thing. If I want all the columns for the fifth row, this is the thing. And if I'm going for the box plot, it clearly shows there's an outlier, and how to fetch that outlier. Okay. And see, outlier is 29.5 is the outlier, and I'm finding the interquartile range. Okay. Already moments package has been installed. So directly I will run the third one, all dot moments, and you can clearly see the first value is 1, the second value is 0, and these are the remaining values. And I'm trying to change the labels to 0 to female, 1 to male. Okay. Once that has been done, I'm able to retrieve only the male data. Okay. So this is the male data, only 111 is there. Similarly, I can retrieve the female data. Okay. Then if I want to find the quantiles, nothing but the quartiles, if I give it, gives me all the quartiles. If I want the Q1, if I want Q2, if I want Q3, I have to give 0.25, 0.5, 0.75, and I'm going to construct the table frequency for the gender column. I can say 25 males are there, 25 females are there. So now let me construct a 2x2 table for gender and exercise. Okay, and I can clearly see female who don't exercise 15, exercise 10, male who don't exercise 10, exercise 15. So I can go for a chi-square test using this, and I find my p-value is greater than 0.05. Then coming to correlation, so there is a positive correlation. I'm finding the regression model. So this is the regression model. What it implies, my weight equal to 68.13650 into this time of height. For any given height, I can find what will be my weight. Okay, so let me plot that. Okay, then plot the fitted line, and if I go for a summary statistics, okay, it tells that this obviously is very less than 0.05. Okay, so null hypothesis fails here, whereas in this case the null hypothesis is true. So I can see there is nearly a good fit, but not I cannot say it is a perfect fit. Okay, I can improve that using a polynomial fit, which is given there. I have commented this because I don't want to waste time. So this is the idea which you can use. Okay, and if I go for multiple regression, and I'm going to run this multiple regression for BMI. So the syntax is BMI tilde. My data $BMI tilde. Then these two are the variables. So this is my target variable. This is my predictive variables. Okay. And see, you can see what the intercept is given, and height and weight coefficients are there. And if okay, so again, since I'm using a scatter 3D plot, let me go to this R. So this will be good for to visualize that. The same thing I'm running with, because I'm not able to get that scatter 3D plot in cloud. I have to see that what is the issue. So I'm just loading car packages, getting loaded. I hope I'll get the figure now. Let me see. RGL is getting loaded now. Yes. Okay, so this is the thing, surface, and these are the data points and this is one data points is farther, and other data points, they're all stick on this. Two data points are a little bit farther than the plane. The other data points are sticking to this plane. Okay, and this is the multiple regression. So now let me come back to this. Okay, so now, ma'am, I will stop here. Thank you for a patient listening. Okay, because it is very difficult to listen for more than 30 minutes. I have taken 2 hours of your valuable time. So I think at least a little bit of thing will push you to know about something about R and work on this. Thank you. I'm open for any questions.
Thank you so much, sir, for your wonderful explanation and presentation on data analysis using R software. We are enlightened with